What's up, everybody? Sparrow with a Gun here from Sleepless Nights with another episode on Space Engineers Programming 101. When we left off in the last episode, we'd started working on our solar array script that's supposed to basically move an array of solar panels around until it's getting the optimal efficiency, which is pretty interesting in my opinion. So, one thing that I noticed after the end of the last episode is we put a clamp so that if you run it through the timer, it checks to see, to basically see if you can, if it's at 0, and if it is, to terminate the velocity so that you don't get the weird where it's like, it's slightly bent over kind of effect. But I didn't have it going this way. And I also didn't have it set up in a position to where if you wanted to turn it back on, that it would work. So for example, if we scroll down here, this was Rx angle equals 0 and then set the velocity to 0. So it's basically if the angle is 0, set it to 0. Well, if you want it to go forward again and it's stuck at 0, then it's creating a loop where it won't ever go anywhere. So I added this where it says and rotor x velocity is equal to -1. This basically checks to make sure it's coming back, and then if it hits 0 to stop, otherwise it lets it proceed forward. We also need to add the opposite line, which is if Rx angle is equal to, what do we have, 135 at the moment? And rotor x velocity equals 1, aka positive, then rotor x set value velocity, oops, is single 0. Now there's a couple ways we could do this. We could incorporate this into the same code, where you have each of these blocks as its own case, so you would put these in parentheses and then put an OR. So if both of these or both of these, then set it to 0. Arguably it's the easier or most compact way to do it. For now we're going to leave it like this just while we're in the testing phase. So at the moment it's set to negative because I was bringing it back. So let's set this up. Now the one thing that we do have to make sure we do is run the timer. The reasoning be that this keeps it checking all the time so that it can test to make sure that everything's going. If we don't run it through the timer, then it still ends up passing its... That's a weird sound. What does that sound? Alright, now if we check our LCD panel, look at me go! 135. Perfect. Now, this also might raise a few questions, such as why do we even bother checking or setting the upper and lower limit and all that if we're going to do it ourselves? That's actually very true. This is more of a fail-safe, I suppose, so I'll probably leave it in there because it doesn't really hurt. But no, if you're setting it like this, you don't actually have to do it this way. Originally, I was going to have it set like this and just move on. I didn't realize, though, that it was starting to cause a little bit, like it would go to 141 or it would go to -5, or, you know, it's not exactly accurate for some reason. It might be how I have the velocity set up, or the velocity is too much for the braking. I'm not really sure why it does that. It's more than likely, I would assume, the weight. The weight of the array is still pulling it over because there's no velocity change. So in checking to change for the velocity, we're basically braking at these limits anyway. I'll more than likely leave these in here, but no, they're not entirely necessary if you set it up like this to where it's going to do it itself. Okay, so the Y, I don't think Y needs an upper and lower limit. It can spin all the way around if it wants to. However, it should be important to note the current angle is set to 360 degrees. this is going to be mildly important because I'd like to have it set up to where when it retracts, it reverts back to 360 degrees. And we'll play around with that at some... There's actually a lot of functionality that I personally want to give this particular script, but I do want to change some things up. I've added some global variables up here so that these are constant. They never change, basically. Well, they could change, but they're always there in the code. That once you get to the main, you always have access to these. Mostly so that we can do things like this, or set the upper limit, or stuff like that. I'm playing around with some few ideas. This is a work in progress script at the moment. I'm noticing things that because I'm not doing it all in one sitting, I'm either overlapping or causing redundant code or things like that. So we've got that moving. Well, the other part we need, and for now, you can change this if you'd like, but for now, I'm going to change this to a 90. And let's see, I'm going to need to bring it back, I think. But the reason for that being, 90 will keep it perfectly upright. So while we're going to play around with these other components of the script, I want it to be set to 90. And see, when I changed to keep it from stopping, the weight pulled it over. There's also one other thing I want to change, and that is I don't like having to alter this code. So what I'm going to do is make a an integer... Well, no. Hold on. I might make another function. And what I'm going to do is call this void... Well, hold on a minute. Let me actually think up how I want to do this, and then I'll come back and we will write it out, or I'll go over it. Okay, so I actually changed quite a bit about the code and how it's set up so that it would run a little bit smoother. I took most of this out, to be honest. I might have to put the solar panel part back in. I didn't really think about that, but the properties and all that kind of stuff I took out. I don't remember where I had the power section, so that I might have to readjust. I'm not sure. But I also added these two lights. Okay? So we got a green one and a red one. If we turn the HUD on with the new tooltips, you can see that this says test light extend, toggle on and off, and this is retract. So basically, I just have these two lights set up to turn on and off, like we've done before, many times. I have the test button panel and the two lights set up, as you can see. So when we go into this, I've changed a lot of stuff around. First of all, we have a global variables section so that everything can be accessed. The reason I did it this way is because it's just a lot easier than having to make every method that you have basically have to poll or accept an argument or something of that nature. So this way we've got all of our rotors, piston, solar panel, our displays up here, our lights are here, we have our limit, our angle. I did take the property thing out. Then instead of declaring the variables, we have instantiating them here. So it's same section, we just took out the actual variable type so that it's not creating a new one, it's just telling it what the value is. So the first time you run the script, it fills all this in, it adds the extend and retract lights to this part, and keeps the angle blank. Now when we get to the setup rotors part, we turn them both off, as we did before, set the braking torque and the upper-lower limit for the X, which we haven't done for Y at all. Then we have a check for state change. This is if extend light is working or on, then we call the extend function. Else if... yeah, we'll want to do an if or. And then retract is working, then we call the retract function. Then we have public display. Let's actually turn this to false. Okay, so I don't have a section for the power, and I don't have a section for the Y angle or the piston. That solves things that won't be there eventually anyway. It's more just for debugging, so I'm not really worried about that at the moment. And then we got the show and the update. Now we get to the extend and retract functions, which I simplified a bit. We have rotor x set value of single 1 for velocity, and then it turns the rotor on, gets the angle, and then it checks the angle against the upper limit. This way we can change the upper limit once, and it will change anything that affects the angle by upper limit. And then it sets the value of velocity to 0 and turns the rotor back off. Same thing with retract, only in reverse. We have it set for -1. Oh, and there's also this, the get angle function that I made. That's down here. So for get angle, it returns a string. You input a IMI rotor or motor stator. I have it set to rotor, and then string temp equals rotor detailed info, and then temp is the substring that we did multiple times to get just the degree value, and then return temp. So in this way we can just call get angle and it will give us what we want. It was just easier. So in theory this should work now to where let's test it. If this is running, it shouldn't be doing anything. Now if we hit retract, there we go. And I should be able to... I think it's going to leave the light on. I haven't set it up to turn the light off, but I have to leave the light on so that it keeps calling the retract function. We could have done that with a state, but this was easier at the moment. Perfect. And we can turn this off. Now, while the... assuming the timer block is still running. Alright. There you go. Now what I wonder happens, I might break something, but if we turn this off... Aha! So if we turn it off, it doesn't call the extend function, and in essence it never... I don't know. I'm not sure if it was supposed to do that or not actually, because I don't think I had any section to turn the rotor off. Okay, I'm seeing something really interesting here. Now, if we set retract, it'll retract. Well, how cool is that? So we can stop it mid-swing. So I think that's actually an accidental byproduct. And what I mean by that is when we have it set up, it disables the rotors. And nothing in this code turns it back on. When you get into extend and retract, it turns it on and then turns it off when it hits its limit. But because we don't have a loop, it's going to keep calling this code over and over and over and over again because of the timer block. So it has to go through the main to get to extend and retract. So if neither of these lights are on every second when the code is run, then it doesn't call either of these, and it effectively leaves them off. So that's interesting. That's kind of a byproduct slash safety mechanism that I didn't really intend for it to do, but it makes it work better. You'll also notice we don't have anything going on our screen at this point, which is a little odd now that I think about it, because we did have the line to display. Oh, it's because every time we run the code, the global variable of angle is reset, and if it never calls extend or retract, then the angle is never filled in. Because we fill the angle in here. Okay, that makes sense, I guess. We could simply have... Yeah, that's the problem. If we get to the point where the lights are off, the timer's going to clear the screen, I think. I think that's what's happening. Alright, so we have the extend and retract of the rotor, of the X rotor at this point. Now what we want to do, and eventually we can do this without lights, we could do it with like little, you know, you could do control panels or whatever. Lights are the cheapest, but they do require power, so on and so forth. So it's all in how you want to do it. There's actually... a mod that I just downloaded. I don't know how the framing for the block works, but they're micro timers, which is pretty interesting. So you could maybe look into doing something like that. So what I want this to do is basically be an on-off. I want it to be completely automated in terms of turning it on and off. Or I mean, once you toggle it on and off, it's going to do its own thing. So now what we need to determine is where the solar panels are going to make the most power. Now, before we get into all that, though, we need to work with our piston to actually do something. So part of the extend code that we need to do is I'd like to avoid, in order to avoid a, like, collision problem where the piston starts to extend as the rotor is rotating the array up and out of whatever containment system you may or may not have on your ship, I want to set it up to where the rotor spins and then after that point then the piston comes out. To do that we'll probably have to either have to set a new function like extend piston and call it at the end of extend and call it at the beginning of retract, which is possible. Actually, that might be our best option. And so we need to check out our solar piston. Oh, it has a velocity. Why do you have a velocity? Huh. That's interesting. I don't know why it has a velocity. It does have a negative, which, unlike rotors, the negative is just going to keep it in place, which might work out fine. Maximal distance. Okay, that all's fine. We can leave that. We don't have to really mess with that. The only reason I would mess with this in the code is if we actually wanted to ensure that it doesn't actually go anywhere. Like, you know, no one can go in and derp with the settings here like you could manually make it all the way out and all the way at the back as being your distances so that no one can adjust it. But that's more of a fail-safe than anything else. Now, the one interesting part here is the velocity is different. For rotors, you have RPMs. For a piston, you have meters per second. I don't know exactly how that's going to play out. So let's write two new functions or methods. I think methods are void. Functions, I believe, are things that return something. I don't remember. But anyways, we'll call this extend, or we'll call it piston extend. That way we can differentiate them. And let's call above or below that piston retract. And like I said, there's always, as you get more into the program of things, you're always going to have to, oh, I forgot about that. Let's do some settings and yada yada yada. So let's set this up similar to what we had before on the rotors by doing piston apply action on off. This is going to be a little different. Let's set the velocity up here. Set value velocity. Now let's try for 1 and see if that... Okay, it doesn't mind that. Alright, cool. So we're setting the velocity and then we'll apply the action of turning it on. Then what I want to check, let's do a display for piston detailed info and see what it returns when it does that. And at the moment we're going to leave it that way. And then what I want to do is at the end of the extend function for the rotors, when you turn the rotor off, we're going to call the piston extend function. That way we're sure that the rotor isn't going anywhere. Alright, so let's test this. Our timer block is still running, obviously, because we can just activate it, which is cool. So theoretically, when it gets to the end, it'll lock itself up and then extend the piston. Like I said, theoretically. Alright, so what's your deal? Your velocity is not different. Oh, you know, we could just do something simple like a reverse. Let's turn that off for now. It shouldn't go anywhere, but it also shouldn't... Oh, wait. What'd you do? Don't do anything. What happened? That was weird. It gave me an error message a minute ago. Whatever. Alright, so let's try, instead of setting the velocity for the piston, we could set that through another means. Let's actually put that up here somewhere. We'll do one for setup piston. And from here, we'll paste this line in, even though it's not entirely working. Let's see if it takes a float. It does take a float. Interesting. Or it will accept a float, anyway. Okay, first of all, let's make sure the piston is off before we do this. On, off, off. That way, we don't have to worry about it actually doing something unless this piston extend is called. Okay. Now, well, hold on a minute. Let's actually comment that line out for setting the velocity, because technically it's already set. So let's try a simple reversal. That should simplify things a bit, because then all we have to do is set... all we have to do is set the... Yeah. I know what I'm talking about. Sorry, programming and talking at the same time don't always go hand in hand. Okay, so detailed info is 90. Oh, okay, I see the problem. I see the problem. So let's turn the light off. Alright, so the problem is, when we're calling reverse, it's just flipping it. But this actually worked. Alright, so our next step... Let's comment this out. Our next step is to activate this, recompile, and see if adding a float... Aha! Now I'm guessing... Where'd it go? Solar piston. Aha! 1 meter per second. Okay, and current position... So all we're getting is 90. I don't get... Oh. Wait, no, this should be... Ah, okay. Let's try this then. Display, right. No, we did that. Update visual? I always... This would be a good time to figure out which one of these actually does what I'm thinking. Okay, it's not update visual. So it must be show public text combined with it. Because theoretically, if this is false, it should be overwriting the angle, and I think that's what's displaying at the moment is the angle. So start. Darn, it's still displaying it. That's so weird. Huh. Alright, is this holding? Okay, it is. Good. Good, good, good. Okay, so that's all well and good, but we need to find the current position. Because I want to compare it. So the current position here, I want to compare that with... Oh, here we go. Let's simply... Oh wait, this is in Piston Extend. Okay. Oh, I see the problem. I'm a dum-dum. I am a dum-dum. So what was happening here is we call extend. Extend calls Piston Extend, which does all this. And then we overwrite it because this wasn't set to append. Dum-da-dum-dum. There we go. Current position. Okay. So what we need to do now is let's check and see if we can display. Probably not. Can we? What's the thing? Yeah, I don't know. I was trying to think of how to get the maximum distance or whatever. But there is one thing I just thought of. It's only in meters. You can only go from 0 to 10. Okay. Okay, then I know how to spin this then. We'll do a string get distance thingy. And we don't necessarily have to do a whole new function for this or method, but I kind of want to. So we'll do, it's kind of similar to what we did before. Piston dot detailed info. Now, what we really need to do is... Yeah, we could probably do it the same way, actually. Temp equals temp substring of index of, and we'll do the colon because there's one in this too. We'll do 2 spaces out like before. I could just copy and paste this. I don't know why I'm typing it. Sorry about that. And then -1 to get rid of the M. Let's try that out. Oh, ha 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 ha. I wrote a function and then did not use it. Okay, so in this part we're going to return get distance and put in piston. Perfect, 10.0. Now we could cut the 0 off, but I actually want to leave it there because what we're going to do is end up comparing it in this. Where is my function? Piston extend. Oh, I put it above. That's weird. I might end up moving that. Alright, so we don't need this part. So basically it's just going to turn it on. We've set the velocity. Actually, you know what? Let's put, now that we know how to make this work, I am going to put this in here. Mostly because that way I don't have to toggle it through this. I can toggle it through my extended functions. We don't need this, but we can check if, let's see, if get distance piston is equal to 10.0, and I'm putting this in a string so that I don't have to actually do a parsing or anything like that to compare it to a number. But if it's equal to that, then what I want to do, oops, is set the value for velocity to 0.0f so that it stops it. Apply action on, off, off. There we go. Now we're going to copy this whole thing and we're going to put it into piston retract. And what we're going to do here is set this to a negative. Now I believe a float can have a negative without being in parentheses. The singles we had to parentheses. And we'll set this to 0 because we want it to stop at 0. Alright, now what we need to do, this part's going to be a little tricky because before we're running it until we get to the point where it needs to stop. This time we actually want it to stop before, or we want it to retract before it moves the rotor. So what we need to do here is find a spot where this is where the rotor turns on, the velocity is set, so we need to put it above this and say we've already known that the retract light will be on or the function wouldn't be called. So what we need to do here is set if, oh, I know, we'll put this whole thing in an if clause. Oops. There we go. Boom. Alright, so what we need to do is say if get distance piston is not equal, oops, to 0.0, or no, is equal. If this is equal to 0.0, then the piston has retracted and we can set up the rotor. Otherwise, or in programming terms, else, we don't actually need to put a clause in there, and we'll just call piston retract. Alright, I think that should work. Alright, so, moment of truth. Oops, I didn't program for that. Alright, so the piston's retracting. And we'll wait for it. Oh, wow. And then at that point, then the rotor rolls back over. And it should stop when it hits this point. Blunk. Alright, cool. Now, the one thing that we need to set up in here as well, just as a precautionary measure, is at this point we also want to turn off extend light by doing the following. So that this way, I don't know why there's an extra A there. This way, it'll automatically turn the light off once the piston is fully extended. And by reverse, we want to do that at the end of the retraction process Oops, not rotor X. What am I thinking? Retract. Spelling. Apply action on off. There we go. So now I don't actually even have to turn the light on and off once it's fully extended or retracted. The lights will turn themselves off. Why I'm getting... Wow, am I getting frame rate lag because of these stupid... Wow, I was. The LCD was lagging up my game. That's funny. So be careful about that. Actually, in fact, we could remove those lines at this point because we're done with those tests at the moment. Let's just leave it as this and put in false. And where did I put the part where it was displaying it? Whatever. I'll find it later. There's a line in here somewhere that's supposed to add to the screen, but that'll clear it. Alright. So, the next step is the Y. We have to get the Y system set up to where it will rotate in the direction of the solar panel. To do that, we need to identify the solar panel's power. So let's put in... we're going to need a new variable anyway for this. We'll call it current power. Kerpow. Just because I like to keep things simple. I just realized I don't actually have to instantiate that because every time it reloads, it should clear. I'll leave it there. It's good. Actually, I should probably put one in here too for this one. Just because I can't remember if globals reset every time the programs run or if it's every time the game restarts. So this, I think, is what you want for when the game actually starts up, so it knows, because it's going to default to these. But this is if you want it to like reset every cycle, which I do at the moment. So let's leave it like that. Let's do set up solar panels, just in case we need to do more than what we're doing here. Okay, so you can't really turn the solar panels on and off or anything like that. But what we can do is set this to display Kerpow, and we'll do this with, at the moment, we'll just do solar panel. How did I do this? Solar panel 1, detailed info. Oh right, it would help if I closed that, wouldn't it? Okay, there we go. Alright, so what we need... I looked up at one point the maximum output, and I'm going to need to check that again. I believe it's like 90 or 100 or something. I don't remember. But we want the current power output. The other thing is it doesn't get past kilowatts. No single solar panel gets past kilowatts. That was very important for me to figure out. So let me run some numbers real quick and check to see what the maximum power is and all that stuff, and I'll be back in a second. Okay, so I was doing some testing. For one thing, I don't know why, but this LCD's panel is not working correctly. When I check the code, it should be refreshing this every time the script's running, but it is not doing that because the one panel that I have connected is like not getting any power at all at the moment, and it's still saying it's got 72 kilowatts, so that's not right. This was basically just me doing some testing to see how the solar panels worked in terms of their wattage, kilowattage, etc. So I opted, just to be safe, to convert everything back to watts instead of trying to just keep it at kilowatts, and that way it would be a little bit safer, that you won't have as many risks of things. I'm going to go ahead and take this out as well. Mostly because it doesn't seem to be working at the moment. So there's that. I did declare a new couple of global variables. I have two floats, current power and optimum power. Optimum power is basically 120,000 watts or 120 kilowatts, which is what the maximum of a large solar panel is. I'm operating on the assumption that you're using these on large ships and stations, or this script anyway. If everybody wants, there is a way to factor in to change this value for small ship solar panels. It's just up to you guys whether or not it would be important or not, or whether you don't care. It's just another if-else clause type of thing of testing what kind of blocks these are, what kind of blocks the grid is, and stuff like that, and then returning it to having it, I think it's 30 kilowatts or something, is for small ships. So I have a new variable here called method optimize power, and it accepts a solar panel called panel. And what I'm doing here is current power is equal to this. This is actually a line that I got off of the wiki, which is a simple way to convert the panel information into regular watts. So you've got 1,000 float times float parse, input the panel, which I have panel, I changed this out, detailed info dot split at the colon, I believe this is to the W, and then you take the fourth element, you trim off the K, and then trim off the extra space either in front or below, or behind, I mean. And then you're probably going to be left with just the raw number multiplied by 1,000 so that you get the watt power. So unfortunately we're out of time for this episode in order to get everything done, but next episode we're going to start actually working on getting it to optimize its own power. Real quick, because I don't actually have time to do the coding part, but real quick, going over the logistics, the part that we're going to have to check is I want to call optimize power at each stage. Basically every second. I want it to call it every second. And if at any point in time it starts to draw less power than it did, I want it to stop. For example, if you call it, just hypothetically, if you call it at the beginning of the script and it's at 120, like you open, say you have it covered in a hangar bay door type of thing, if you open it and it's at optimum power, we don't want it to go anywhere. So it's one of those, I want it to check every stage so that, like, if the rotor only gets to this point, but because of the angle of your ship, it's receiving optimum power, or it receives less power when it starts to flip this way, I want it to flip back to where it was, and then stop itself, and so on and so forth. And then, same thing with Y, is that it'll spin around basically until it reaches optimum energy. Stuff like that. Let me know what you guys think about ideas such as that, as far as, would you rather it extend all the way and then check, or do you want it to always check all the time so that you're getting the optimum power? It does cause, it would cause bigger issues for setting the thing up, in terms of you'd have to make sure that it can stop halfway up if this is full power, and so on and so forth. But let me know what you guys think about that kind of stuff. In the meantime, I hope you all enjoyed. If you did, leave a like, and I will see you all next time. Peace.